Okay, let's say now we are asked to find this. Find the particular solution of the following differential equation: x dy dx equal to this, and then given y equal to 0 when x equal to 1. That means you are given this condition is for you to find the constant c, because you are asked to find a particular solution. Okay, so you see how I solve it. I show you the example. Okay, this is the differential equation given. And then first of all, you see how are we going to solve the differential equation. Is it separable variable? You try and see. If it is separable, then we try to use separable. If not, then we try other methods. So altogether we are going to learn 3 methods. So this is the second one. So x dy will be equal to, I show you this first. I'm trying to use separable variable. So this is dx. So now the problem is this x I can bring over here. That's no problem. This y and this y, can you bring these two y over here? Which is impossible. We cannot do that. So that means this is non-separable, because this x I can bring. You see, I can bring this x easily over here. Okay, but the problem is how to bring over these two y. We are unable to do that, so this is called non-separable. So if non-separable variable, the formula that we have learned before, the method that we have learned before that cannot be used. So we are going to use this. Okay, now we try and see, is it homogeneous? How to know whether is it homogeneous or not? This is a to the power 1. This one I say already, a to the power 0, isn't it? Because 1 over 1, a1 over a1, this which is a0. So that means this is a1, a0. So the power is a1. Here is a2 plus a2, degree 2. This is a, and then because this one got square root, so you still get a plus a. So the degree is a1, isn't it? The degree. So a1, a1. So this is homogeneous. So I told you already, homogeneous, always we substitute with this. Okay, y equal to dx. So whenever you see the y, then you substitute with this. Therefore you have x d dx. Okay, substitute the y, substitute the y. Then you try to simplify everything. So this one you should know, you differentiate vx. So you have v, differentiate x, you get 1. Then x dv dx. Then this one I just substitute. I can bring out the x here. And then after that, the x, I can cancel. Actually here got x, but all these x cancel off, isn't it? So after that, I will get this. So you simplify, you will get this. Okay, the v and the v you bring over. These two v will cancel off. Therefore, finally you get this. Okay, so this one you'll get after you simplify. And then you can see that after you simplify, whatever you get here is definitely is separable variable. I told you already, every time homogeneous, I substitute this. The purpose is to change homogeneous into separable variable. So you see, separable variable, I bring the x over, then the v I bring over here. Then you see I can integrate now. Okay, this one negative. Okay, this is ln x plus c. But here you want to integrate this. Here you must have a 4 here. And then this is 1 over 4, isn't it? That's why I get 1 over 4. And then this one, integrate, you get plus 1. Okay, you get this, then you simplify. Okay or not? So now you have already got this. And now what am I going to do? Because I want to find a particular solution, I have to find what is the c here. So how to find c? Because you are given x equal to 1, y equal to 0, isn't it? The condition just now. And then but here we have v. So I can find the v from here first. I substitute x1, I substitute y0, I get v equal to 0. Okay, then after that I just substitute the v inside as 0. I substitute, that's why I get c also equal to 0, because this one plus 1 plus 0, 1 plus 0 is 1, so this is half. Then this one ln 1 is 0, that means c is equal to half. Okay, you substitute inside. Then after that you just bring in the c, that is the particular solution. But the solution we require should be in terms of x and y, alright? So we must have x and y, so you must change back the y into the v into y and x. So it's this one, so this is the answer. Okay, so this is the particular solution. Okay, Okay, then you look at question 27. Okay, you look at question 27, you are given this. Okay, so you are given this question 27. You look at your question 27. Again, this one is non-separable. You can try and see this is non-separable. Okay, so what we have to do now, this is actually, you see the top one, this is y square xy over xy minus x square. So this one degree 2, so it's a2 over a2, so it's a0. Here also a0, so it's homogeneous. So homogeneous, we substitute y equal to ux. We are again trying to change this one into what we call separable variable. Okay, so we try to change this into separable variable. Okay, let's see, I show you where is the question now. This is question 27, am I right? Okay, I have the question here. I show you the question easier. Okay, here is the question. Okay, now you look at the question here. I have the question with me here. 27, you see. The variable x and y satisfy the differential equation. Show that by substituting. Actually here this is the partial question. Actually here is homogeneous, but they never tell you it's homogeneous. They straight away ask you to substitute. Then you can transform the given differential equation into like this. Okay, so we are going to show, and you are given 3 marks. Then afterward, hence find the solution of the given differential equation for which y equal to 2 when x equal to half. This is STPM question. Like this, you will get 9 marks. Okay, so now I'm going to show you. So this part I will show you just now. This is the one they give you. Then and after that, you just substitute all the y. You substitute into ux. Substitute. Then you simplify. This one you differentiate. Okay, this part you simplify, you know. Then after that you will get this, isn't it? This is what we are asked to show. You see or not? Correct? Same. Okay, so this is what you get. This is the one. Then after that we are going to solve. Hence we are going to solve separable variable, because I told you already, every time becomes separable variable. Then you bring the u over here. Then after that you integrate. Okay, you bring over here. Then this one, the numerator you can separate, you get 1. This one you get u negative 1, and then this one integrate, you get a c here. Then integrate this, you get u, and then integrate the other one, you get ln u, and then equal to 2 ln x plus c. Now we are asked, you have to find the c, because you are given the initial condition. Okay, you are given y equal to 2, x equal to half. Okay, so you substitute. Okay, and then you see here I have only u and x, isn't it? So I find the u here, then I substitute. Then I find the c, I get c equal to 4. Okay, then after that I substitute back into this here. I know the c is 4. I substitute back the 4 inside here. Then I substitute. Then I have to change the u back into y and x like that. Okay, so you simplify. I think this one you can go through, then you get this answer. Okay, so you can try this. Afterward I give you another example, another 2 example. Okay, so you look at this one first.